Thanks for the opportunity to present this OMOP-to-FHIR conversion tool. I'm speaking on behalf of the tech team that was responsible for the transformation, including Shaheen, Saeed, and Michael Kahn. This tool is available on GitHub. Just look for MENS on FHIR. So the goal of this tool was to support MENS. MENS stands for Multi-State EHR-based Network for Disease Surveillance. They do chronic disease monitoring. So the tool would start from the top left. You plug to any OMOP database. We have Python scripts that would flat the records. We need all in one piece to generate the OMOP JSON files. These files are run into the WISO engine, which has libraries, rules for transformation, and the mapping. And then the result are FHIR bundles, a FHIR bundle with FHIR resource. Then we validate the code, the file generated with the FHIR validator. And at the end, we upload that to a FHIR server. For this demo, I'm using Happy FHIR. For the project, we use Google Cloud Healthcare Firestore so that the MENS group could do a Firebulk and use for data analysis. As a data partner, would be we need to create a FHIR code that was conformant with FHIR R4 and FHIR US Core, and we will be doing this, generating this data quarterly for supporting the surveillance. So the first thing is seeing the data. I'm going to show here one example of the data. Here we have conditional occurrence. In conditional occurrence, we have the conditional ID, and we do a join and bring all the data that's necessary. So we flatten the record and have everything in one place. Then in the WISO is a language for transformation, and it's based on a Go language. It uses, we can use the concept mapping from FHIR. So here we're using the FHIR concept map resource to generate the mapping. So you can see the source coming from OMOP, going into the HL7 value set for ethnicity. And the code, this code for Hispanic would be transformed into this code for Hispanic Latin in the FHIR version. And you do that for ethnicity, race, and some other places that we need to do the mapping. And then we have the WISO transformation. The WISO transformation code, I'm going to show directly in the source code. You write the code to decide how that data that's coming in is going to be transformed into the FHIR. For the drug exposure, for example, we use the type concept ID. If it is 32818, a standard code for administration record, and the drug source value vocabulary ID is a CVX, we build a immunization FHIR resource. If not, we build the medication administration. If the type concept ID is 32833, EHR order, we create a medication request. If it's this code, which is dispensing record, we create a medication dispense FHIR resource. And for all the records, we create medications. And just to give an example, we don't have a UI for this tool. It's code we do in batches. We supported 3.24 million patients that met the MENS inclusion criteria, and that we didn't have an interface for this, just processing and getting the results uploaded. So when you see the WISO code, you have the left side is the FHIR data element. On the right side, you have the OMOP data element that's being added during the transformation. Sometimes we just create our own. So here it's creating a resource, a FHIR resource type medication request. The ID is going to be this. We are loading a profile, informing the profile that's going to be the data for this FHIR resource is going to be using US Core. So the server should know what type of data is going in, and you have other information. We had to do some assumptions and some generate rules. For example, here, if there is a stop reason in the drug exposure, we create the status for the medication request as stopped. If not, we just do a no. And some other assumptions that we had to create to map the data between the two data models. So then we have a process. I'm showing step by step, but this can be automated and do the whole thing in chunks. So here, the convert grabs the data from that JSON file with the OMOP data, converts, uses the whistle and generates the JSON file. And now we can see, for example, the condition occurs. He's now in the file format. It's an entry for a condition. We can see the code is now a codable concept in FHIR. The encounter is linked to the encounter ID that was generated. We have onset period, and this is a resource type condition. So the next step in this process is to validate the FHIR resource. And the way we do this, we load the FHIR validator tool, and then we also inform which IGs, the implementation guides, we want to use. So here you can see FHIR core, it loads terminologies, it communicates with the terminology server from FHIR to validate the terminologies and codes. And then for each document, each file converted is validated against these IGs that were loaded in all these libraries. So now we can see the result of this. When we run the file validator, it can generate a report. Here you can see the report generated for each document, the errors, the warnings, the hints, and you can look the way we did. We ran this, went back, revised, refined the rules, and went to the process. We end up the project for this presentation with a validation rate of 1%. But there are some errors that we could not resolve because when you're dealing with FHIR in US core, you have some issues in there and some other things like here we can see, this is a Cynthia data, but you can see here that unknown code. So the code that was used is not known by the terminology server, and that would give an error. Back here. So now that we have the validation, as soon as it's correct, the next step is to upload to a FHIR server. So here I'm doing a FHIR request, asking for all the conditions, and just to show, this returns a bundle with 0. So the FHIR server is empty as of now. We can then run the load model. It's going to load all the files that were converted to the FHIR server. And then we can do another FHIR request. Here we are asking to read the condition number 1. And then now this is coming from the FHIR server. So we'll complete that loop, that process, that data flow to get to the FHIR server available for use. And you can see here the resource type. Because it's already in FHIR, it generates some metadata. One was updated. Have the language, have the code as was shown before, the links to patient, link to encounter, and set date period. And then the next step, now the mains could get all the data that's available. Here I'm going to do an example. Now I'm making a request for all the conditions in FHIR. And now returns a resource bundle with 20 entries just for this demo with entries of conditions. So here you have a resource type condition 1 and you have all the list here. So the final step in this process is that we can actually go to the FHIR server Here I have a Happy Fire running on my laptop, and we can go to the condition resource to search and see the 20 entries here and see that's available. So the next step in that process would be this process. So that goes from OMOP to FHIR, then the mains will do the next part. Just one last thing to show. This process, as processing time here from OMOP to OMOP JSON, remember 3.24 million patient data, 30 minutes, OMOP JSON to FHIR server, which is the demo I just completed, 39 hours, the book FHIR 30 minutes, and then importing into the mains network in analysis system around 80 hours. So that is my presentation. I'll open for questions.